see in this meeting. So I will tell you a bit more about this this component. So as George and Doug mentioned, I mean, component A, it's just the kind of natural extension of the CMIP5 first attempt based on what we've learned with this exercise. So like doing the forecast every year and having enough members to get some statistics and so on. So it's just natural extension. Component B is also natural extension of the CMIP5 and linked to what society needs and the demand, especially in line with the WCRP Grand Challenge and climate services. And component C is a kind of new challenge here for CMIP6, and this is, as mentioned by George, this is why we are essentially here. It might be a little bit complicated because it's kind of new, and the rationale for the existence of this component C is that we need for much better understanding of the mechanism and processes determining decadal variability and predictability. So we have to go beyond the simple skill of prediction, and we have to understand why we have skill and why we don't have skill in some areas. And so we need to come up with some coordinated experiments to do so. So we need to improve our characterization, our simulation, and our understanding, including the attribution of the past decadal climate variabilities, which I will phrase in a more global how can I say, expression, which is the modulation of the anthropogenic warming trends, basically. So a little bit of history of this component C. So we have two milestones on our trip to Aspen, I would say. The first one is the Hague, the list. So a meeting happened last year in Netherlands, the CLIVAR meeting, where we come up with a list of lessons that we learned from CMIP5, and the idea was to pick some of them to go into component C and to get some coordinated experiment about this. So this is a kind of the list of the question we had. So I'm not going to go into details in all of these questions. Just the main bullet is we need to. A question in a lesson we learned from CMIP6 is that we have a kind of, I mean, we have predictability over the ocean, but we have very weak predictability over land. And so we need to better understand why we have this loss of predictability with the ocean and the land. Also, we have a lot of regional differences in predictability and skill. And how can we explain then, especially the difference between the Pacific and where we have weak predictability, I mean, past 2 or 3 years, and the Atlantic, where we can have an extension of this predictability up to 10 years in some cases. We also need to understand the relationship between the low frequency, I mean the multi-decadal variability in the Atlantic and in the Pacific. How are they connected? What is the role of the forcing in setting decadal variability? What is the interaction between this natural variability, natural modes of variability, and the forcing? And obviously, what is the role of the ocean initial condition in climate prediction? And also the last subject is extremely important for decadal forecast is the role of volcanic forcing. So we listed these items at the Hague meeting, and we selected two items for this component C experiment. So the role of the volcanic forcing, and Leon is going to talk about it a little bit just after me, and the ongoing hiatus. So maybe the term is not good because maybe hiatus is ox apparently. So we may change this a little bit. But behind this general phrasing is just the modulation of the trend that we are experiencing. So the goal of this component C is to design some model experiments to tackle these hiatus issues and also the volcano. And we need to come up with some coordinated experiments that benefit to the entire community, that are cheap in terms of resource, because the component A is very expensive and a lot of computer power and storage. And this experiment should also be as easy as possible and easy to run. So for the hiatus question, so the scientific question we would like to ask with this coordinated experiment is to assess the spatial and the seasonal footprint of this mode of variability and the contribution of the forcing and the internal variability. And we also want to understand the mechanism of the hiatus that are present in models and why they are so different between models, because we have a zoo of mechanism for the same, I would say, final product. The AMV in some models can be triggered by some mechanism. In our model, it's completely different mechanism, but we end up with kind of low frequency fluctuation in the entire North Atlantic. So after this list, we thought about, we discussed a lot about this, and we find some kind of problem or issues is that the climate community is very mobilized on this subject, and it can be extremely difficult to come up with coordinated experiments because all the groups are really involved in this issue. And we may find some reluctance of the modeling group to perform new coordinated experiments about this hiatus stuff because they have done their own experiments and then use their own protocols, and it's going to be hard to convince them to kind of redo their experiment. So we may need to broaden the problematic, I would say, and may want to put the hiatus as part of the global problematic, which is the modulation of the anthropogenic warming trends. And so we want to understand the previous hiatus as well as the decades where the global warming accelerated. And we want to assess what is implied in terms of predictability. Okay, so the two focus are really on the AMV and the IPV, and what is the role of these large-scale ocean modes of the decadal variability, and what's the role of the forcing in these two modes. So we came up with some ideas to do some pacemaker experiments in line with Xiangping did before, and we came up with two types of experiments: the Pacific pacemaker experiments, so similar to what Xiangping did, and the Atlantic pacemaker experiments to really have a focus on this AMV and to try to answer all of this scientific question. So the second milestone on this road to Aspen is the SPECS meeting that happened in February, last February, where we came up with a draft for this component C experiments. Also, I guess you can't see here, but you have three types of experiments with the volcano that Leon is talking about. He's going to talk about this later. But the first experiments with priority 1 are pacemaker experiment following the work by Kosaka and Xiangping here, and with over the period 1950-2015, 10 members and so on, and we have to agree on this restoring timescale for the pacemaker. The second one is the same thing for the Atlantic, but extending over from the equator to 60 north. And then in tier 2, it would be great to extend this pacemaker experiment back to 1820 to have some to investigate especially the warming in the North Atlantic in the 1920s and 30s. So this is in tier 2. And in tier 3, we want to, as Doug mentioned, we think that there's not a fault, but there's a lot of evidence that the South Polar gyre is very important for decadal prediction in the Atlantic. So we want to rerun the forecast, actually the hindcast that in component A, but without initializing the South Polar gyre to assess the importance of this region in terms of predictability. So shall we go a bit further with this experiment? So, and especially what is missing is the understanding how the external forcing interplay with the internal variability. And we may want to come up with some more idealized experiments that the community can share. So, just a brief summary. We agreed as a DCPP member that we don't want to make any priority between the components for the CMIP 5 exercise. So we've put some priority in each component But we don't want to have priority in component by himself, because we want to allow the maximum of modeling group to participate to DCPP, and because it's very much resource demanding, we want to welcome groups that don't have a lot of resource and are very interested in this subject. Also, what we try to do is to have Component C helping for tackling issues that are promoted by the new panel set up by CLIVAR, which is DCVP. So for Decadal Climate Variability Panel, this is a bit confusing. Johannan is going to talk about it later this week, but we want Component C to be part of this dynamics, starting with CLIVAR. And this is the last sentence I had it in my specs meeting. In February, we need to test protocol before labeling as semipsis run, and as George said, we are here to finalize the component. So what we hope to have in this meeting is a lot of discussion about the pros and the cons of the experimental protocol, what we are going to propose for semipsis, and what is the scientific rationale of the experiments. We possibly want to revisit the first draft of Component C experiments that we had in specs. And the last bullet is like some new genius idea may emerge from this meeting, because apparently this meeting has been a seed for a lot of nice projects for the community. So we may come up with something original and genius.
Okay, thanks. Good question.
So I'm not trying to respond to point 3. I just wanted to ask why are we ignoring solar variability? We are talking about external forcing, in this example, the volcanic forcing, and of course the greenhouse forcing, and maybe aerosols too, but we are ignoring solar. Is there any particular reason for that?
That's a good question. I mean, solar forcing is included in the INCAST. But yeah, I don't know. We haven't
issues of the mechanism, right?
That's true. Yep.
There,
involving the stratosphere and all of this. Yep.
in the MIP structure, and maybe somebody here.
Is there a MIP?
There's a solar MIP.
Oh, there's solar MIP.
But
okay.
it's been they got 7 modeling groups to agree to do the runs, and nominally you're supposed to have 8, so they were kind of on the bubble. We're actually getting approval as a MIP. They were trying to merge one of their experiments with the detection attribution MIP. Not quite sure what's gone on with that. So there is a solar MIP out there. So if this could be a connection to them, we'd have to figure out exactly what they're.
There's also a volcano MIP too. So
Volcano MIP, exactly. Yeah.
It doesn't mean that we shouldn't keep an eye on this.
So Yoshi and then.
I agree with scientifically very interesting topic. So I just wondering about technical model. So if I prescribe just only one region or something like a pacemaker experiment, some model may have a significant drift or they have many model biases. So is there any suggestion to that?
I think we are going to talk about this issue during this workshop. There are there's 2 or 3 talks at least about this problem that we may face with pacemaker experiments. We have to be very careful in the design of these experiments to avoid these kind of drawbacks. Yeah.
John.
I just wanted to say that the pacemaker experiments are fine, but they're also large initial condition ensembles, and people are finding they can get the same information in a large initial condition ensemble than you can from a pacemaker experiment, but in a fully coupled and self-consistent.
Yes. Yeah.
I don't know what my suggestion is, but just a certain awareness that these are also a valuable resource and shouldn't be ignored.
Sure.
And it might, in some instances, be better than a pacemaker experiment.
Yes, definitely. Yeah, we have to include this.
I just want to comment a little bit on the solar and more general. I think it's really the question how our models are capable also of doing such experiments. And in particular for the solar, we have really to have a good stratospheric resolution. Maybe we have also had to have interactive ozone.
Yeah.
So I think, of course, a lot of things are interesting, but we have also to face the reality how good our prediction models are and what they can do, and then start from this on. and do then maybe other experiments, or together with other MIPS, some more.
Yeah, I think, everything's on the table, really. I mean,
Yes.
we can, at this meeting, we can come up with anything that we think makes sense. Paco, I think you made the name.
Yeah, you didn't say anything about the convenience or not of using the same model system, or the same version across the different
Yeah.
components. And this is
Yeah, I forgot about it.
probably
Yeah. This is
important also if we interact with other MIPS, like ball MIP or solar MIP, because it's quite likely that we'll end up with different configurations.
Yeah, I think, at least to me, the key point is to have the same model version and the same component between the three component of DCPP, because I think a component C may help a lot to understand the predictability of component A, and this is actually the target of component C. We need to understand why we have predictability and why we don't. So this is extremely important. We need.
Why don't you come on
Yeah.
up, and then we have one more question for Matthew.
Well, it's just a comment on your comment, John, which was, I think an initial condition ensemble, you mean an initialized set of runs, right? Would maybe be equivalent to a pacemaker experiment if you're designing the pacemaker experiment to reproduce what happened in the real world. If we want the pacemaker experiment to test some hypothesis about what happened in the real world, then I don't think that's the equivalence isn't there. So if we wanted to just say, is it the heat fluxes? Is it the upwelling? Is it the winds which have caused this particular recent event? So we might think about in a bit more detail about how we would design a pacemaker experiment and what hypotheses we want to test.